Okay, so we're going to do electricity problems, and we're going to do the series and parallel today. So we'll start with question number 1. So what I'm going to do is I'm going to write my given, and I'm going to write my find. So when I read the problem, it says a lamp having a resistance of 10 ohms, so R is 10 ohms, is connected across a 15-volt battery. So the battery, which is the total voltage, we're going to say is 15. What is the current through the lamp? So I want to find IT. And what resistance must be connected in series with the lamp to reduce the current to 0.5? So we actually want a new IT, which is 0.5. So not in that part. So what I'm going to do first is I'm going to draw my schematic diagram. So my schematic diagram shows here I have one resistor. Well, it's actually a lamp, but I'm going to call it a resistor because all our problems we're going to do resistors. And that's in series with the battery, and the battery is 15 volts. So the current coming out of the battery only has one path to go. Whenever I do circuits, I'm going to do Ohm's law, and I'm either going to apply Ohm's law to the entire circuit or just part of the circuit. So remember, Ohm's law is V is equal to IR. Okay. So I'm going to apply it to the circuit. So if I do the whole circuit, I'm going to say VT is IT times RT. So if I want to solve for the current, IT is going to be VT over RT. So it's 15 volts over 10 ohms, which would be 1.5 amps. So that's all I do for part A. Now part B might be a little confusing, and part B is very similar to number 5, which are a little confusing. They're not very straightforward. So for part B, it says what resistance must be connected. So basically I want to add another resistor, and I don't know what that resistor is. So what resistor has to be added in series with this to reduce the current to 0.5. So my new current, so the new, this is part B, the new total current has to be 0.5. So what does that mean? Well, what I'm going to do is I'm going to apply Ohm's law again and say VT is equal to IT times RT. So RT is equal to VT over IT. So the total voltage is 15, and now they want my total current to be 0.5. So what I'm getting here is that my total resistance is 30. Now on the sheet, I know this says 2, but the reason that says 2 is the book did it in correct significant figures. I just want you to leave it at 1.5. Does everyone understand? Okay. So don't be concerned that the worksheet says 2. Now remember, if you're taking a standardized test, they're always going to have the correct answers and correct significant figures. All right. Now this is my total current. Now remember, in series, the RT is equal to R1 plus R2. So in this case, my total current, which is 30, would have to be 10 plus the one I don't know, R question mark. Does everyone see that? So basically, our question mark is going to be 30 ohms minus 10 ohms. So the resistor I'm going to have to add is going to be 20. Does that make sense? So you see here, I'm using my equation for resistance for series. So I know in series, the resistances add up. Does everyone see that? Okay, so this one and number 5 are different, and then the ones you have in between 2, 3, and 4 are ones where you have more than one resistor in series. So again, you're going to draw a schematic, you're going to write your given and find, and everything else. All right, now we're going to move on to a parallel. So the parallel are only 6 and 7, so we'll do number 6 together. So I'm going to start off with a fresh piece of paper. So we're going to do number 6. So number 6, I'm going to write my given and my find because that's going to help me. So it says a 6 ohm, 18 ohm, and 90 ohm resistors are connected in parallel. So I'm going to say R1 is equal to 6, R2 is equal to 18, and R3 is equal to 90. Across a 36 volt potential difference. So the battery is equal to 36 volts. And then it says find what is the current through each resistor. So I want to find I1, I2, and I3. What is the total current? So I want to find IT. And then it says what is the effective resistance of the circuit? So I want to find RT. So first I'm going to draw my schematic, because when you know that when we do combination pictures, we use our intermediate schematic diagrams to solve. So I have 3 resistors in parallel. So remember, whenever I'm looking at a circuit, you think about the current going through the water, like water flowing through a pipe. So there's only one place for it to flow here, but then it splits, and then it splits again. So I'm going to say R1 is 6 ohms, R2 is 18 ohms, and R3 is 90 ohms. So that's my schematic diagram. So remember, what I'm going to do, whenever I do problems here, I'm going to be using Ohm's law, V is equal to IR. And I'm either going to apply Ohm's law for the entire circuit, or I'm going to apply Ohm's law for each little branch within the circuit. Okay, so one of the things I know about in parallel the voltages are equal. So VT is equal to V1 is equal to V2 is equal to V3. So what does that mean? That means this is 36 volts, this is 36 volts, and this is 36 volts. So now I'm going to apply Ohm's law to find the current. So I'm going to say I1 is V1 over R1. Remember, I'm just taking Ohm's law, I'm rearranging it to solve for I, and then I'm applying it for just this branch. So I1 is V1 over R1 is 36 volts over 6 ohms, which is 6 amps. Then I'm going to say I2 is V2 over R2 is 36 volts over 18 ohms is equal to 2 amps. And then I'm going to say I3 is V3 over R3, which is 36 over 90, which is 0.4 amps. So all I did was apply Ohm's law to each branch. I is equal to V over R. And I knew V because I knew in parallel the voltage drop is the same across each branch. And again, what you have to do is you have to practice. Practice makes perfect. Okay, so let's look at part B. It says find the total current. Well, I know in parallel the current adds up. So IT is equal to I1 plus I2 plus I3. So that's going to be equal to 6 amps plus 2 amps plus 0.4 amps. So IT is equal to 8.4 amps. All right, for part C, it says find the equivalent resistance, okay, or the effective resistance. So now for part C, I'm going to say 1 over RT is 1 over R1 plus 1 over R2 plus 1 over R3. So 1/6 plus 1/18 plus 1 over 90. So 1 over RT, now I'm used to doing it with common denominators. Again, you can use your fraction button if you want. 15 over 90 plus 5 over 90 plus 1 over 90 is equal to 21 over 90. So 1 over RT is 21 over 90. So RT is equal to 90 over 21, which is 4.3. So that's how I find the equivalent resistance. Now, the great thing about circuits is you always have a foolproof way to check your work every single time. So that's what I'm going to do now. I'm just going to do a check to make sure I didn't make any mistakes. And when you're doing combination circuits or complex circuits, what you want to do is you'll kind of want to do these little mental checks as you're going along. So I'm going to apply Ohm's law to the whole circuit. So VT is IT times RT. So IT is equal to VT over RT. So the total voltage was 36 divided by what I just found, 4.3, and it comes out to be 8.4 amps. Now, is this 8.4 the same as the total current here when I found it by adding up the total current in each branch? Yes. So do you see here I have a way to check my work? Okay. I go back and I say, let me just check my work. So again, I can apply Ohm's law to each branch, or I'm going to apply Ohm's law to the total. And again, you have a foolproof way to check your work every time you're doing a problem.